This is lesson 26 on page 120 in your book. It's called One-Step Equations Using Addition and Subtraction. Please turn to the page. Let's read the target together. I can solve one-step equations by relating an equation to a diagram and checking to determine if the solution is true. At any time during this lesson, you may need to use the pause button. You may want to go back and double check the examples that we've done together so that then you can continue to do them in your book. You're going to be asked to use the pause symbol each time that we're doing a new exercise independently so that I'm not showing you the answers ahead of time. We're going to solve each equation. We're going to use both tape diagrams and algebraic methods to solve for each problem, and then use substitution to check our answers. Now, in order for you to learn how to solve multi-step equations in future grades, you first must learn how to solve basic equations. And although this may be simple and something that you think you can do in your head, you have to understand the steps that are involved in order to be able to do this when it becomes more complex. So we're going to draw two tape diagrams that are the same length. Let's label the first one 8. The second one is going to be the a plus 2 part. So we know that a small section of this will be the 2. And just by knowing math, we know that this part has to equal 6. So what we're really looking at in this diagram is we have 2 and then the a. The a becomes the same size as the 6, so that lets us know that a equals 6. A plus 2 equals 8 is an algebraic equation. Now we want to use an algebraic method to solve. We're going to think back to a previous lesson when we discussed identity properties. How could we explain why a plus 2 minus 2 equals a? Give you a little time to think about that. Well, what we know is that when we add a number and then subtract the same number, our result is the original number. Let's try another one. A plus b minus b will equal a, because again we added and subtracted the same number, so we are back, the result will be the original number. So let's take a look at a plus 2 equals 8. If we have a plus 2 and we subtract 2 on one side to equal 8, in order to keep this equation the same, we're going to subtract 2 on both sides. What happens is that we're left with a on one side and 8 minus 2 on the other side of the equation, of the equal sign. So now we can solve for a algebraically. 8 minus 2 equals 6. And this is what we found before with the tape diagram, that a was equal to 6. When we go back to do our check, we're going to go again write our original equation. A plus 2 equals 8. We substitute the 6 for the a, and then we do the math and solve, evaluate each one, and 8 equals 8 lets us know that this is a true statement. We are on page 120. We're going to solve each equation using both tape diagram and algebraic method for each problem. Then we'll use substitution to check our answers. So as we take a look at the first example, b plus 9 equals 15. Our first activity will be to draw two tape diagrams that are the same length. The top tape diagram will be the whole, or 15. We're going to divide the bottom tape diagram into two parts, b and 9. Mathematically, we know that 9 plus 6 is going to equal 15. So we have b equaling 6. Let's take a look at how we would solve this algebraically. We write the algebraic equation b plus 9 equals 15. We're going to use the identity property to get rid of the 9 basically. We want to make sure that b is by itself so we can find out what it equals. So we have plus 9 minus 9, and we are going to write 15, but remember to keep both sides of the equation equivalent, we have to subtract 9 from both sides. On the left side, where our 9's cancel each other out, so we're left with b, and 15 minus 9 equals 6. Now we're ready for the check, where we always start with writing the original equation again, b plus 9 equals 15. We're going to substitute b. We're going to put a 6 in its place and write the equation 6 plus 9 equals 15. And then when we solve this, we can see 15 equals 15. This is a true statement. Now, you should be on page 121. If you're not on page 121, pause the tape and get to page 121. We're looking at the equation 12 equals 8 plus c. They've used a little bit of the commutative property to change the order of the equation, where we have the 12 first, or the answer, as everyone likes to call it, in front of the equation. Is that going to make a difference in how we solve it? Not a bit. So let's start by making our two tape diagrams, drawing two bar diagrams the same length. The top one will still be the whole, or 12. The bottom one we're going to divide into 8 and c. We know because of our math knowledge that when we are going to solve for c, we know the answer is 4. c equals 4 in the tape diagram. Now let's take a look at solving with algebraic method. 12 equals 8 plus c. As we're taking a look at this, we want to know what c equals, so we want to get c alone by itself. And in order to do that, we have to get rid of that 8. We're going to use the identity property. It's a positive 8, and we know that if we add a negative 8 to it, it will equal 0. So 12 minus 8 equals 8 plus c minus 8. And once again, we have taken 8 away from both sides in order to keep it equivalent. So on the right side of the equal sign, positive 8 minus 8, we're going to be left with c. And on the left side of the equal sign, 12 minus 8 equals 4. Let's do our check. We begin again by writing the original equation. 12 equals 8 plus c. We're going to substitute the 4 for the c, and we end up solving the equation 12 equals 12 is a true statement. We're on page 122 now, looking at exercise 2. We have an equation of d minus 5 equals 7. So now we've got to change our brains around a little bit and remember a couple of things. First of all, we want to go over and explain that when we have the identity for a subtraction, that if we have minus 5 and we add 5, then we're going to be able to end up with d, which is exactly what we need to have in order to solve this equation. So we're going to be using addition this time instead of subtraction on both sides of the equal sign. The second thing we want to remember is how would we show subtraction in a tape diagram. So let's start by drawing one tape, and this time we're going to identify this as D because we're not sure what our whole is. As we divide D, we know one part is 5 and the other part is D minus 5 that equals 7. So if we have D and we're using this 5 on the left as a subtraction, then as we rewrite the tape diagram, again, the whole thing equals D. We have two sections, 5 and 7. And so now, as we go to figure out what D is, 5 plus 7 equals 12. So D equals 12. Let's get ready to solve this algebraically. We're going to write D minus 5 equals 7. We're going to use the identity of negative 5 as positive 5, and we're going to make sure that we do the positive 5 on both sides of the equal sign to keep the equation equivalent. Negative 5, positive 5 cancels each other out. We're left with D, which is exactly what we need. 7 plus 5 equals 12. So we've proven this algebraically. And now we need to perform the check. Writing the original equation, D minus 5 equals 7. We're going to substitute 12 in for D. So 12 minus 5 equals 7. And in fact, 12 minus 5 does equal 7. So this is a true sentence. Our solution is correct. On page 123 and 124, there are 3 exercises for you to work on independently. Even though the directions in your book say that you may choose which method, either the tape diagram or algebraically, you prefer, I'm asking you to do all 3 steps on these pages to show the substitute. I want you to solve with a tape diagram and show the algebraic method while also checking your answer for each time. When you go to do your homework tonight, then you can pick and choose a method that you prefer. So you're going to go ahead and you're going to solve each of these 3 equations. You're going to raise your hand and show the substitute, your methods, and your checks when you have finished, and then follow whatever directions the sub gives you at that point. Remember, you may always go back and look back at any of the diagrams that we've done in the past in order to check and see that you're on the right track, and always use the pause feature as needed. Have a good time.